इसको पहले
So very good morning to all of you. Sir is there?
Yeah. Yes.
Sir, so very good morning to all of you. Today we have the webinar on the geospatial technologies. So before hand over the session to our speaker, sir, we have a brief about the geospatial technologies. Geospatial technology is basically a tool that contributed your geographical mapping and analysis of Earth with your society. Basically, these technologies has been in 19th century and the your basically the these are basically important for your school, colleges, and many your map making, photography, cameras, and like that you have the science of photographic interpretation. And in during your you know about the Second World War and during the Cold War, it will take another new dimension and advance the satellite based on the computers. So be as the satellites allowed the images your Earth surface that the human activities there will be the certain limitations. So computer and the storage which Please mute whosoever is unmuted. Please mute. So these are the basically an important tool to capture your images and interpretation. So basically, these an important aspect like your GIS ability to assemble the range of geospatial data into a layer of maps, which basically allows you complex themes to be analyzed, and then it will be communicated to the wider audiences. So on this word, uh, I'm introducing the today's speaker, Dr. Gauri Sankar Bhunia. He has a very vast experience, done his PhD, uh, and currently he's working in the as a GIS expert. Also, he has worked as a uh, your resource scientist and many other organization as a manager and GIS expert. He has done many major projects to the GIS works and approx 70 publications in this field. So on this word, I hand over the session to Gauri Sankar Buria sir.
Thank you, Dr. Vijendra, for your good introduction, and it's a pleasure to welcome here. And I'm very much thankful to the organizing committee and the principal sir for giving me this opportunity. And also, I'm thanks to all of you that you all are coming here today. And I would like to share my observations and knowledge regarding the remote sensing and the geospatial technology. So this technology is, if we can think that the combinations of GIS, the remote sensing, and other cartographic techniques, and as well as also there are a lot of means uh, mathematical and physical science are also applied to get the informations about the Earth surface. So I thank you once again to Dr. Vijendra. So today in our lecture, we'll discuss about the first aspect of remote sensing, because this is the first aspect in geospatial technology where we are getting the informations for analyzing the data or for mapping purpose, whatever Dr. Vijendra described here. So thank you guys. Now I'll start my lecture. I'm just sharing my presentation. Is my screen is visible?
Yes, sir.
Yes, sir.
Okay, okay, thank you.
Yes,
So today we'll discuss about the basics of remote sensing, and in today's class, uh, I'm just trying to focus on the what is the remote sensing technique. Maybe I know you all are very good and having some basic knowledge of this technique. However, as per the introduction, I'll share some of the remote sensing process and some Earth observation system that is going on, and how these technologies come to light, and how we'll use these informations, and what are the aspects we need to consider when you do some geospatial mapping or means analyzing this information. And then there are different types of platforms and satellite. So there are we are here the information that like communication system, like extraction of the features of the Earth surface, or analyzing the information or prediction information. That so this information, how it will come, and what are the satellites maybe used or is going to be used, or be now using by the scientists and the or planners to providing this information. And there are types of remote sensing technology. that will also helpful to understand that when we do some work or would like to do some work, then which type of remote sensing data we need to use, or we need to acquire this data so that we can get the correct information, or we can extract the correct information, and some of the examples of the data interpretations, and finally the resolution of the sensor. That means whenever we're going to do a project of on remote sensing technique, so resolution is one of the most important factors of the sensor that will provide such the opportunity that which type of data we need to consider, which type of resolution we need to consider for analyzing the data or getting the informations or extracting information from the satellite data or the geospatial data. So first of all, the interaction that if we ask about the remote sensing, what is the remote sensing defined? Remote sensing is a technique that help to acquiring information about the Earth's surface features without any physical contact. There's one picture you can see here. That picture is showing that there are some electromagnetic radiation is striking on Earth's surface, and some sensors that are getting these signals. And on the other hand, there are some objects which are also reflecting or emitting the electromagnetic radiation, and there are some receiving station that is collecting this information from the sensor, and then it will there are a lot of processing has to be done to getting this information. However, in the next slides we'll discuss in details that what are the process and when to follow, or the remote sensing techniques is followed for information acquiring. So overall, if you consider that our human being, like our eye is the sensor here. She just observing this phenomena, and based on its observation, it will provide the or signals to brain, and identify the what exactly the feature is. Either it is, for example, roads or buildings or vegetation or water bodies, etc. So there are different remote sensing scientists, those who are providing information of the remote sensing, like Dr. Professor Savins, who has defined that it's a science of acquiring, processing, and interpreting of the images that record interaction between the electric energy and matter. What are the features in our Earth surface are available. So each object or each features have some different characteristics of radiation or reflection of the electromagnetic radiation, and this radiation is captured by the sensor, and then it will be providing the signal to the Earth receiving station, and based on the signal characteristics we are able to identify what are the features. So why this technique basically we are adopting? Because there are a lot of advantages of this technique. So for example, as a human being or as a camera, whatever available right now, so these are can be visible only some certain uh, distance. Like, say for example, you can say maximum 1 kilometer or 2 kilometer distance we can cover. After that, we are not able to identify the what are the features are there, means if there are any changes that we don't have such a records. So remote sensing details help us to keeping these records. It is a vast aerial coverage that at a time we can cover approximately thousands of square kilometer area. It has a capability to collect the information temporarily, like historical information, so that we're able to identify the changes of the features, what are the changes are there, and lot of features that the human being are not able to identify through its visibility. or the perception. So once we get the informations of the digital information, so there are a lot of technology is now going to be introduced, and a lot of processing techniques are available there. So based on that, we are accurately and timely with low human means intervention, minimum human intervention, we can gather the information, so use this information for our planning purpose or for the development of our society. So, as if, for example, if we can see that if a person is not a remote means geospatial technology expert or remote sensing expert, or having not such an idea about the remote sensing technology, so in that case, how it will be differ from the experts of remote sensing and the non-experts? The experts of remote sensing that once he getting the image, he will identify the spectral characteristics. He will be identified the what are the features are there. He can categorize the features that what are the informations are there, and based on these informations, he will be able to characterize the Earth surface without any means observing the particular area, or no, without any field verifications of this particular area. However, as a non-experts, that means the person, those who have not a knowledge, not having a knowledge about the remote sensing technique. So once you will getting the data of this information, so you just observe that this is a color image, and means it will take different types of means colors are represented there. But what are the colors are describing there? What are the features are describing there? And what tools we need to be used to identify this information or analyzing this information? That is not possible by non-remote sensing experts. And sometimes it is also not able to identify that which type of data have been used. So, for example, when you're doing a project or something, means proposed a plan, so we need to understand that which type of data we need to use, and which type of methodology need to be adopted. And based on this, these observations, we are means reducing our budget, we are proposing our budget, or we are planning for that. So in that case, as a non-remote sensing expert, he is not be able to identify these characteristics, and not able to understand that what type of data we need to be used for this project or for this particular type of characteristics, analyzing these characteristics. So it's just give a little brief introduction about the history of the remote sensing, that before 1840, when the camera was first introduced by Leonardo da Vinci. At that time, the remote sensing technique is introduced. So we can say it's approximately about the 150 years ago that this techniques is used. That the idea or the practice that has been come from by developing of the camera obscura in 1840, where they have just installed the camera in the balloon, and they are just observing the Earth's surface. And then in during the First World War, when the enemy they have used the camera using the pigeon, and they're collecting the informations about their enemy's position, or the topographical characteristics or topographic distributions of these particular areas, and they are planning for that and to striking on based on this visibility or the images by the Fijians, filmed by the Fijians. So remote sensing technique has been started since that period. However, the developed country currently use this technique much more. In India, still we are now in ongoing stage or developing stage. You can see that we just have started this using this technology, and means trying to uh, adopting this technology to getting the information from the remote sensing data. So in India, if you can see that this technology is initiated in 1960 when the first Indian satellites, Arjavata, which has been launched in 19th April 1975, was first launched this Indian remote sensing satellite by Indian Space Research Organization. And then they've used the two TV cameras that is named by Vaskara 1 and 2. And after that, they have used some experimental satellites and Rohini series. And finally, in 1988, the Indian remote sensing satellite first launched into the space to collect the information about the Earth surface features. And as you know that we have uh, mainly the ground control stations that are collecting informations of the signals from the remote sensing data, which is located at Bangalore, and our National Remote Sensing Centers, which is located at Hyderabad, for acquiring this data and processing this data. Now we will discuss about the components of remote sensing. That there are several components that is considered in the remote sensing technology, like source of energy. So the main source of energy on our Earth surface is only the sun. But however, currently there are several remote sensing technologies also being adopted, that the sensors is use their own source of energy to collect these informations. However, we'll discuss in later in details. Then it's interaction with the atmosphere. Once the source of energy is means they have just transmission that we have seen in our Earth surface pictures, that sun's radiating their energy into the Earth surface, and then it will come into the shortwave radiation, and then it will interact with our Earth surface features. However, before interacting with the Earth surface features, the atmospheric layers are there. So all the means atmospheric layers are not means all the signals from the suns are not able to penetrate this atmospheric layer. Some of the signals, some of the energy is absorbed by the atmospheric layer. Say, for example, ozone layer, so that which is absorb the ultraviolet radiation. But there are some areas in the atmosphere which is work as an atmospheric window, that is help to pass the electromagnetic radiation to our Earth surface. And then interaction of this atmospheric energy or the sun's energy, it interact with the Earth surface features. Like what are the Earth surface features that are available? It's maybe the artificial, or it may be the natural features of our Earth surface, and it intermingles with the objects depending on the characteristics of both the object and the emission. And then after interacting this electromagnetic radiation with the Earth surface objects, the energy has become radiated and from the target, and it will captured by the sensor, which is based on the either air or the space. So this sensor is received the transmitted energy and or the reflected energy or the emitted energy. After receiving these informations, sensor again transmitted the signal to the ground wherever antenna is available to capture these signals. Ground stations, that is we have seen that in case of the India, that in Bangalore there are number of ground stations are available for each satellites and sensor. Whenever they are sending the signals, they will capture these signals using this antenna. And these signals again transmitted to the remote sensing lab. That may be the numerical or the imaging characteristics, and then some analysis or processing has been done to interpret this data, and finally we'll get the outputs of the data, either it is a image format or the numerical format or uh, metadata informations. And these informations will used by the remote sensing experts or the planners or the geospatial experts, those who are identifying these characteristics or analyzing this remote sensing data as per their applications. So there are a number of applications that are available in remote sensing technology that we may see in the applications of remote sensing in hazard assessment, application of remote sensing in agricultural assessment, agriculture in different types of crop estimations, like some hydrological features identification, topographic characteristics identification. So at the last stage, during the applications, people are using this data after processing or means finalizing these information, and then identify the features whatever the exactly available on our Earth surface. So you just provide give little examples, like how this electromagnetic radiation, that this solar radiation, like some of the reflected or emitted energy, and we'll discuss later that this electromagnetic, within this electromagnetic spectrum, only few parts or there are some visible and thermal and the microwave part. The energy will come into the Earth surface and interact with the Earth surface features. And after interaction with the Earth surface features, it will reflect it back towards the sensor, and then sensor captures these reflected informations or the electromagnetic radiation characterize the Earth surface features available in the study area or the regions. So when this energy will come into the Earth surface, this will come as a low shorter wave, or the high energy will come. But after interacting with the Earth surface features, the longer wave will be found, and that will be the lower energy. So therefore, the sensor, we need to be calibrate these informations that is found due to some geometric or some of the radiometric characteristics. Geometric, that means the sensor capability, the sensor characteristics, that what is the means resolution, what is the its capacity to capture, right? And for the radiometric, we have found that these atmospheric characteristics, like the different types of atmospheric materials are available. The vapor, and there are a lot of dust particles are available there. So these features will interact with these energies, and sometimes we're getting some means net informations or the signals, some noise signals. So with that, we need to be calibrate, so that if you have the remote, if you are a remote sensing expert, so if you have the knowledge on the remote sensing technology, so that you are able to identify this noise or the errors, and then after calibration, you are able to process, means analyzing this data to get the accurate information. Otherwise, once the noise or the error will come, so the misinterpretation can be happen, because we are depending on the spectral characteristics. So that means the energy or the means spectral strain that will be reflected by the objects or after interaction of the object of the Earth surface. So once we are getting the correct image or without noise image, then we can get on with this data, accurate data or accurate information. So for example, here I have given an example of the spectral behavior. I just consider on the spectral characteristics of the vegetation. because in vegetation, what we have seen on our Earth's surface, that it's look like a green. Why it is green? Because it is reflected by green energy. However, the other energy like blue, red, or the other near infrared portion of the electron energy that has been absorbed, or the near infrared energy is also being reflected rather than the green energy. But unfortunately, as a human being, our perception is, or means our visibility is limited up to the visible energy or visible band of the electron spectrum. So, for example, the blue, green, and red, these are the three visible source of energy or visible light that we can only observe. We are not able to observe the infrared radiation. Therefore, do not identify the infrared radiations that is highly reflected by the vegetation. So once we are going to means identify this vegetation of an area or the vegetation characteristics or vegetation hills or vegetation means the leaf saturations or the means water content within the leaf. So we need to consider this infrared wavelength and the red wavelength. Why red wavelength? Because this red wavelength is much more absorbed by the uh, leaf. So one we are going to normalize these informations that red and near infrared. This will be help us to identify the vegetation conditions or vegetation health of this particular area or the particular vegetation. Then I have given some examples that how these different types of earth surface features that will interact with the electromagnetic energy or electromagnetic spectrum. And using this remote sensing technique, we are able to we are identifying this phenomena that without interaction or without any physical contact, that what are the vegetation characteristics there, what are the species are available there, what are the means vegetation hills are there, right? So you can see that if we trying to identify that this classification has been identified three main method wavelength categories. One is the visible, and another one is the near infrared. That we know that our visible range, which is extended up to 0.4 to 0.7 micrometer or 0.6 micrometer of the electron spectrum, and the near infrared range that is extended 0.7 to 1.3 micrometer or 1.4 micrometer of the electron spectrum, and then short wave infrared that is approximately 1.3 to 2.6 micrometer of the electron spectrum. So once we are going to identify the characteristics of vegetation, you can see if we consider the leaf pigments only. So we need to consider about the blue and green spectrum of the electron radiation, because our leaf pigment that will absorb the blue and red spectrum of the electron radiation, but it reflects the means green radiation. So based on its means chlorophyll absorptions, we are able to identify the leaf pigments of the surfaces. And then cell structure, like what is the cell's conditions that either the disease is captured this leaf, or sometimes the in agricultural characteristics we are able to identify that we need to is there any disease affected or not, so that we are using this near infrared portion of the electron radiation that will be helpful to identify the what is the leaf conditions and cell structure of this vegetation content. And there are the water content, like water absorption bands. We have found that in 1.4 micrometer, 2.4, 2 micrometer, and 2.6 micrometer, but the water absorption bands are there. That means the atmosphere layer, that it will penetrate this electromagnetic wavelength. So we are not getting any information with this particular spectrum of the electron radiation. And therefore, we need to consider that 1.5 to 1.8 or 2.1 to 2.4 at the spectrum of the data, so that we are able to identify the water content of this. Why I'm telling this type of information? Because we are just when designing the sensor or means identified the sensor characteristics. So within the sensor characteristics, number of filters have been used. So these filters will be captured this information or this part of the electronic spectrum, so that based on this signal strength or the signal characteristics or the spectral properties of the signal, where we'll be able to identify the water content or the cell structure or the leaf pigments of the vegetation. In the same way, I've just given an example of some of the reflecting characteristics of the soils, buildings, and vegetation, roads. So each features of our Earth surface having some different reflectance. So once we get these informations, or once we are able to identify these informations, we can easily identify these features within a very short period of time, within a very large area, and the more accurate informations that will be not able to not possible by through the conventional surface, you can say, because it will take too much time, or means increasing the project cost, or means people are may not get the accurate information because a lot of obstacles are there. Now I talk about some of the platform that I've already talked some about means what are the different types of remote sensing data. When you're going to collecting these remote sensing informations, we're using the platform, so that this platform having each of the platform having some different applications based on our purpose of study or attaining the informations about the Earth surface. So what is the platform basically? Platform is a device where the remote sensing sensor is mounted. Say for example, if you consider that our head, our head is the platform. So within our head, the eye is our sensor. So in the same way, when you are means launching the satellite, so after launching the satellite, it will be set up into the platform, and this platform will be helpful. Will help to connect to mount it the sensor within the satellite for acquiring these informations, or these informations is when collected by different types of filter used by the sensor in the satellites. So this platform are majorly classified as a two major characteristics, like fixed platform and the moving platform. This fixed and moving platform can be identified or can be considered on based on some several phenomena, like its distance between the sensor and object. So, for example, we need the data from the lower altitude, or we need the data from a fixed location. uh, so, therefore, we are just considering our the distance. We are identified the threshold of the distance that will between the sensor and objects, and then periodicity that I've told earlier, like remote sensing technology having the advantage that it will take the information regularly or frequently or at a certain time of interval. So based on its periodicity, it will collect the informations about the surface features, and then timing. Sometimes we are you may heard about this technology that the information has been collected from the daytime or night time, because some of the information which is not able to visible or not able to possible to collect during the daytime. So at that time, say for example, during the Diwali, you can see that the Indian Space Research Organization has published several data that what is the illumination characteristics, what are the means how many lights are there, and what is the energy consumption by the city. So when we are trying to getting this type of information, we need to take the nighttime images. Therefore, timely information or timing of acquisition we fixed based on the platform. And another important characteristics of the timing that as you know that if you consider the space in northern hemisphere, when it is the day, in the southern hemisphere it is night. So uh, as we discussed earlier that the illumination source of energy of our earth surface is the our source of energy only the sun. So once the location position of the sun, we have to fix our sensor or the satellite on its platform. That whenever the day is there, the satellite will be passed through this, within this regions or within this hemisphere, with this hemisphere. So and that way we have fixed our timing and the location of extent. It's very important because we are not means without any permission we are not able, we cannot collect the informations of the border area or some other countries area. So that is a limitation. So therefore sometimes you can see that there is a collaboration between the different countries with India, so that they have collaboratively collect these informations by launching these satellites or increasing the capability or capacity of the sensor in different aspects and collect the informations, as well as sometimes the phenomena or the natural calamities or the factors that is not happen in the inter-regions or in the interior. So once we need to collect the informations, there's a lot of cost, a lot of issues are there. So we have to collect this informations only particular this area as per our requirement. And another important characteristic is the storage capacity. So once we are trying to acquire the informations regularly, so sometimes there is a space of the storage of this data might not be feasible. Therefore, considering this type of difficulties or considering this type of factors, we have also limited our collection of information based on its location and extent or based on the purpose of use. So this platform, fixed platform that we have characterized like a cherry-based or tripod-based. You can see an example of this cherry-based platform. Or the sometimes you can see that people are taking photographs or images by installing them tripod in the stations and capturing this information. And moving platform, there are two major moving platform. One is the airborne and another the spaceborne. So in airborne, like balloon or balloon based, that I've given an example earlier also. That means First World War, when the first remote sensing satellites are launching, and the enemy's peoples are trying to collect the informations by mounting satellites or the sensor in the balloons. And there are some aerial platform like aerial photographs. You can heard about this term. Or recently the drone data, right? It's also an aerial platform that we are installing these informations, installing this satellite or sensor with the drone or the aerial aeroplanes, and we're trying to collect the informations of the Earth surface features. And this, in case of the spaceborne, there are two important platforms are there. One is the geostationary, and another is the sun synchronous. That geostationary that is used for the spaceborne having a distance or height, you can say, like approximately 36,000 kilometers from our Earth's surface. And in case of the sun synchronous, it is fixed at a range of 700 to 800 kilometers from our Earth's surface. However, I will discuss in details in my next class about the geostationary and sun synchronous. Now, just give an example of the ground platform that there are in the right side. You can see that we have fixed a camera and we are observing a target, and we are acquiring these informations, and based on this target we are trying to identify what are the features are there and associated phenomena there that are responsible for this development or for these characteristics. And however, it has this ground platform are basically employed to record the comprehensive informations about the surface, and it has some basic advantage like a lot of atmospheric attenuations are there. So sometimes the clouds are there, or whenever the dust particles will be there much more, or water will be there. So we're not able to identify these features from the space, because it will make hindrance. And in case of the ground borne platform, when you are going to use, then it is easy to handle, and it's also used to support the scanner to extend it our information. However, this type of platform basically used, whenever we are going to design the sensor or the spectral characteristics of the features. What we have done, we'll just go to the field and collect the informations, or collect the spectral characteristics. So this is the characteristics of, you can say, the ground-borne platform of remote sensing technique. So that this identifying these features, or during the designing of the sensor, we'll use this features, or use this platform to getting the informations, or correcting our or determining our threshold value of the sensor. However, a disadvantage, because once you are going to trying to collect the information for large areas, or means there are the limitations of the ground-borne satellite, that they are not too much means high quality of sensor. So that if we are going to means trying to identify the different characteristics features, sometimes it is not possible to identify using this ground-based platform. And then airborne platform. However, the airborne platform is mainly straight in the aircraft or helicopter, or as I told you, that drone right now. So it has some basic advantage that it can fly relatively low altitudes, that is approximately about 7 to 8 kilometers. Or in case of drone, we are now that we are considering like 400 meters or 600 meters from the Earth surface. So that the aircraft can easily avoid this phenomena like weather problems, that like due to the clouds, or which may blocks the sensor, satellite electromagnetic spectrum, or electromagnetic signals to reach on the ground. And sensor maintenance or repair or configuration, that is also be feasible or easy to handle by the sensor designer, or the satellite designer, or those who are or the engineers, those who are involved in this field. And it also means you can if you want to collect the information within a particular area, where we are defining the boundaries of this particular region. So it will be feasible, or it will be possible to collect this information in that way. But there are some also disadvantages there, that getting permissions for flying the satellite, to take the permissions from the government authority, because once you are getting the permission, then you can only fly the airplane or the drone to collect this information. And sometimes low altitude, due to this low altitude, since acquiring many passes means to cover the suppose of 50 to 100 square kilometer, you need to collect means more than 100 or more than 200 times you need to pass this area to gather the information. Because of the low altitude, it will cover the lower extent or the its boundaries of the place, and it's turned down the time it takes to get the data, that sometimes it's delayed due to some means weather phenomena, or we need to wait once the clear sky will be there, then we can gather the information. Then we'll consider about the space-borne platform. For the space-borne platform, that there are different types of satellites, like sun synchronous or geostationary, whatever I'm talking about earlier, that it comes under the space-borne platform. Where the if we consider that moon is our natural satellite, the same way we have just mounted our satellite into the space. Either it is the sun synchronous or the means geostationary. That sometimes there are some space shuttle that has been launched at 200 to 300 kilometer, or some low level satellite 700 to 800 kilometer, or the high level satellite like 36,000 kilometer, like geostationary satellite. So these are the space-borne platform where the satellites installed into the means placed into the space and collecting information about the Earth surface features. Our different types of radiometric and geometric errors are found because of the atmospheric characteristics or atmospheric attenuations, and it's to analyze this data. There must be some knowledge about the remote sensing technology. Otherwise, it's become difficult to identify what are the features of there, what are the means pixel characteristics or the sensor characteristics of these particular features. So it has a lot of advantage, like it has covered a large area. It can collect the frequent information or means quantity measurements of the ground features is very much means accurate, and we can identify the area or the features over a large area within a short period of time. And once you cover the large area, it will be your cost of the satellite of acquiring information or launching of satellite acquiring information that will be less rather than the airborne or the ground platform. So this is the example of the remote sensing satellites, that how it will be placed into the space, like they are all spaced in the elliptical orbit, and based on the locations or based on our means identifying the phenomena or analyzing the phenomena, we have where means scientists or planners are trying to place these satellites at different angles. And these angles may be the polar orbit, like sun synchronous. If you consider, it's also known as the sun synchronous, where mostly the satellites are launched at 850 kilometers from the Earth's surface and having an angle between 80 to 105 degrees from the equatorial plane. And it is basically launched means rotated from the north to south. So almost whatever the Earth surface features we need to identify, in that case we are using the sun synchronous satellite, or we are considering the sun synchronous satellite data, so that it will means capture the information about the Earth surface features. And why it is sun synchronous? It is because that we are just placed this satellite based on the sun's position, or the considering the sidereality, that is the means light of the means sun will fall into the Earth's surface, and based considering this characteristics, we are mounted this satellite into the polar orbit. And there are another important orbit, like Equatorial Orbit, which is placed at the equator, or the satellite must be launched from the place of the Earth, which is close to the equator. So it will be placed at 0 degree, and its height basically 36,000 kilometers from the Earth's surface. And another important characteristics that this Equatorial Orbit or this geostationary satellites is basically used for the communication purpose. Like we are getting the radio signals or the mobile navigation system, etc. All these things are depending upon this Equatorial Orbit or Equatorial Orbit satellites. So this is examples of the sun synchronous and the polar orbit that I've already described about, like that it combines the altitude and inclination of the objects that orbit ascent or descent over any given point of the Earth's surface. And this it must consider about the surface illumination angles that will be approximately the same with the illumination angles of the sun. Therefore, it is known as the sun synchronous. And in case of the geostationary, that it is almost the 0 degree of angles or the latitudes placed within the Equatorial orbit, and they have the same spots with a periodical, that is the Earth rotational periods. And it basically its condition differ in the locations of the longitude only due to its constant 0 degree latitude. And some of the means geostationary objects that appear motionless in the sky from the Earth's surface, that because of the communication purpose and the basically we are using for the weather forecasting. Now coming to the sensor, that another important part of the remote sensing technique, or you can say sensor. So we are getting this information either actively or passively. So what sensor will do? Sensor will just capture this electronic radiations from the Earth surface and it converts it into the signals or the based on its capability, and it then transmitted or transmitted to the ground antennas. So after transmitting this information, we are analyzing or processing this data and identified the features of the Earth surface or getting the information either in image form or non-imaging form. So this sensor can be classified two important characteristics. One is the passive sensor and another one is the active sensor. And passive sensor, why it will passive sensor? Because this will depends upon the energy source. That is the it's don't have means if during the cloudy conditions or the suns will not means found or the this much solar illumination angles not available. So we are not able to identify or we are not able to collect the accurate information of the Earth's surface without this energy. Because once the energy will come into the Earth surface and interact into the Earth surface features, then it will be just reflected into the space, and then the sensor only captured. But in case of the active sensor, what will happen? The sensor having its own energy, so that it's not depending upon the sun's energy. So therefore, it will collect the informations about the Earth surface features either day or night or any time, or there are some passive sensor that having the disadvantage like during the cloudy conditions or the if there is a lot of atmospheric attenuations are there, so we are not able to collect the information from the passive sensor. So in that case, we need to choose about the active sensor. So for example, in radar or lidar data. So in our remote sensing technology or Indian Space Organization have developed the RISET program or RISET satellite or Mars. There are a lot of satellite sensors are there also that will collect the active sensor and collect the information during the monsoon seasons or night time. So these are some basic classification of the sensor. If we consider that sensor, there are two major characteristics. One is the active and passive sensor. Like active sensor that I've told you earlier, that it has own source of light to collect the information, whereas passive sensor is used the source of light as a sun. And from the both the sensor, we are able to identify the different any scanning or imaging data or non-imaging data, and imaging data that may be the object plane or image plane that we'll talk later. When the object like mostly the microwave satellites, those were collecting the information like real aperture radar or synthetic aperture radar. Means we are just using the size of antenna to collect the information that what will be the size and what are the when it will be fly, means how it will be collect the information, what are the principle it need to be followed, that we have defined. And in case of the passive sensor, mostly in the imaging purpose, like optical, thermal, and microwave, that will discussed one by one in the next slide. And we are also non-imaging sensors. Sometimes we are able to and means we need to getting informations of the ocean area or the water bodies area. So in that case, the informations are non-imaging or non-scanning, we can say. So we are using the lasers or altimeters or radiometers to get this information or to identify the features of the surface available below the water bodies. Then these are some basic classifications between the or the means differentiation between the passive and active sensor that already I have discussed earlier with you. And next, I'll go for the imaging and non-imaging sensor. Like sensor provides the output that image will get. Sometimes you may see the image on the surface features, and sometimes we are getting the non-imaging or numerical information or the basic data. That based on that we analyze these informations to getting this sensor phenomena. And imaging sensor having the high spatial resolution that we will discuss later about the resolution. At the time, we'll discuss about what is the spatial resolution, what are the high spatial resolution, etc. And for the scanning and non-scanning sensor, there are two ways that satellites are working, or the sensors are collecting the information. One is the across track, and another one is the along track. You can see, this is the along track, that what the sensors are means capturing the information in a particular features or particular path, that whereas the across track will means to collect the information by column wise. And then we'll discuss about the types of remote sensing, like that I've shown you earlier. For the imaging sensor, we have basically the visible or thermal or microwave sensor that they are. So if we majorly classify this type of remote sensing, then there are optical sensor system, which is considered about the visible or reflected or infrared portion, and the thermal infrared portion. And for the radar system, like microwave, why we are going to use the microwave? Because that the sensor or the active sensor, basically, these are using this microwave data. Sometimes the cloud or any conditions, or it can penetrate the signals approximately 1 to 2 meter depth of below the Earth's surface. And sometimes the solar illumination angles are not available, and so in that case we need to consider the microwave remote sensing or the active remote sensing technique. So if we consider the types of remote sensing, that there are three major characteristics that we need to understand, and recently we are using, or the entire world are using this types of remote sensing, based on the purpose or the applications of use of the remote sensing technique of the Earth, techniques of the Earth. And first, if you consider the optical remote sensing technique, that optical remote sensing technique, that it's you can say it's a visible, it's just consider the visible part of the spectrum, which is ranging between 0.4 to 0. Means 3 nanometer, or the 3 micrometer of the spectrum, where it will consider the visible, near infrared, and the short wave infrared portion of the spectrum. And in that case, it will helpful to interpret of the data by composing the different types of electron spectrum bands in multispectral image, or the panchromatic image, or the hyperspectral image, etc. And another important characteristic, like disadvantage, that it's not possible to collect the information like nighttime or the cloudy conditions. So the people's means satellites are not able to capture the correct information due to its clouds coverage, or it cannot penetrate the clouds, basically. So these visible remote sensing techniques can be classified as the panchromatic imaging system, multispectral imaging system. Panchromatic, why panchromatic? That means there is only black and white picture, or the one band will be available there, so that you can see that earlier we have seen our means photo, or the video, or the movies, which are mostly the black and white pictures. However, once the technology is going to advance, we are using the color picture now, 3D movie, 4D movie, 4D visualizations are there. So in that way, the technology is also advancing, and earlier we are trying, able to collect the panchromatic imaging system, which is using the one bands, and then we are trying to collect the information of the multispectral imaging system. That is, there are number of minimum 3 bands as required. And superspectral, there are some the sensor or satellite have been designed that having a sensor electron spectrum band, that 10 to 50 bands, or so what is the exactly bands? The bands is that we are using the filter, or we are using the different types of within the sensor. Number of optical scanners are there. So each optical scanner is collecting the informations of this particular wavelength of using this filter. You just detect only this particular wavelength, or acquire this information. So one of optical sensor or optical features that is formed, that is represent the one band of remote sensing data. So, for example, there is one example that you can see that this is the panchromatic band, where you can see the black and white pictures. So the single channel or the detectors are sensitive to the radiations within a broad wavelength range. If you can say the visible range, or optical range, like 0.4 to 0.7, the entire spectrum will be within this range of the, or whatever the image we have received, it is considered the interspectrum. But when we are going to multispectral, it will separate the band or separate this optical or visible range like 0.4 to 0.7. It is classified at 0.4 to 0.5 is one band, 0.5 to 0.6 is another band, 0.6 to 0.7 is there. So these are classified, this electron spectrum, the number of band, number of spectral channel. So that after combining all these spectral channel or spectral bands, you are getting the multispectral data or the color images. And then superspectral, that where the means more than 10 spectral bands are used, and we're able to identify the different types of features. So we'll discuss it in the details in our resolution section. So I'm just a quick look on this factors, or the quick look of this imaging system. And then for the hyperspectral imaging system, whereas it is also known as the imaging spectrometer, that it appears the images about 100 or more continuous spectral band, and this precise spectral information contains in a hyperspectral images, that is enables the better characterization or the identification of the features. Sometimes why are you using this type of band or imaging system? Because sometimes we have some applications we need to classify, or we need to identify this data in details. We would like to identify the features only, like only water bodies. So, for example, so water bodies, you can get the water bodies area, the extent, or the if there is any changes in the particular time period, that is possible. But the if the suspended material or the means stability conditions you need to understand, then or the water depth you need to understand. That in that case, you means. Identify, means you used to consider the different spectral band, or the hyperspectral band, the superspectral band, so that you will be able to identify these features based on this hyperspectral imaging system. And then thermal imaging system, that is used basically 3.5 micrometer to 18 to 14 micrometer range of the electron spectrum. So by the thermal remote sensing, what will they will collect the immediate radio spectrum of the immediate energy of the object, and the sensor is able to collect this immediate energy and helpful to identify the based on temporal characteristics or temperature characteristics, the features can be identified. So it has a lot of advantage, like it is simple to operate, and impact system are moderately priced, and it is not when you're going to identify the phenomena during night. So this technique is very much useful to identify the object. So there are some of the regions, like recently there is a strikes was there in our border region of Pakistan, India border region, that they have used the thermal remote sensing data to identify the enemies, or the position of the enemies of the Earth surface in this border region. Sorry. Then microwave remote sensing. Microwave remote sensing basically used the wavelength range of 1 millimeter to 1 meter of the electron spectrum. So this microwave remote sensing, we have seen that during the cloudy conditions, or the means rainy season times, or the monsoon season, specifically used because optical remote sensing or the visible remote sensing don't have the capability to collect the information of the object, or don't have the ability to penetrate the clouds or the rain to gather this information. So sometimes there is an urgency, or there is we need to collect the information to analyze, or to for the estimations, or for the planning purpose. So in that case, the active remote sensing is used. So this active remote sensing will be helpful to collect this information at that time, as well as it will also collect the information at a ground. It can penetrate ground at a 1 meter to 2 meter depth, so that users are able to identify these features. And sometimes whatever the cyclones or the weather phenomena that we are going to predict, in that case we are using this microwave remote sensing techniques, because this microwave remote sensing techniques, based on its active energy, or means based active signal stream, it will help us to identify these features. And say for example, I've just given an example of the NASA, that they have predicting the cyclone, or the intensity of the cyclone, or the cyclonic eye of the cyclone, that and extension based on this microwave remote sensing data. Now coming to the image resolution, that we have read about this term earlier number of times. Our now we'll discuss that what is the resolution. Basically, resolution is nothing but about it's the resolving power of the sensor. That say for example, if we consider sometimes there are so many people that who is not using the glass, and there are some people who are using glass. So that means once you're why I'm talking about this. So it's your eyes capability, in the same way the sensor's capability to capture this information. Sometimes there are so many people are there, and you can hear that yes, I can visible after 10-meter distance, 50-meter distance, what exactly features. And some people are there, those who are not able to identify the features after 10-meter distance. So this is the basically you can say that the resolving power of your eye. So in the same way, the satellite sensors having the resolving power or resolving capacity to identify these phenomena or features of our Earth surface. And these resolutions we can identify it in remote sensing in the four major category. One is such as the spatial resolution, another in the spectral resolution, and then radiometric resolution, and the temporal resolution. And then just talking with them one by one, that what is the spatial resolution? Spatial resolution, you can say that how much it is scanned by sensor at an instant of time. Like once you have open your eyes and close your eyes, then you can see that area that you have covered, that is your spatial resolution. So this the sensor having the spatial resolution, that some there is some example that I have defined here, that number of pixels or the pixel areas, and I have classified that is 30 meter, 5 meter, or 1 meter. So once you have the pixel size, or your coverage area is 30 meters, so you can able to identify the features which is extended within this 30 meter by 30 meter area. So once you are going to identify the features having a 5 meter by 5 meter of area, so you need to define or need to acquire the data within this 5 meter area, or having the sensor capability to capture this 5 meter area or 1 meter area. So based on characteristics, we are classified as the very high resolution, that is less than 5 meter pixel size, then high resolution 5 meter to 100 meter pixel size, and moderate resolution, etc. So this spatial resolution, another application is that sometimes we need to take information, or we need to estimate the information about the entire country or the entire region. So in that case, if we consider this means high resolution satellite data, then our project cost or the cost will be much more higher. So in that case, when we need to get details of the information, or degree in details will be increased. So we'll just increase our spatial resolution data, or we'll take the information and very high spatial resolution data, so that say for example, I just give you example one, like these are the data having the different spatial resolution data. You can see the image having the 188 meter spatial resolution. So you're just getting some information overall, that what are the means rate are there, blue are there, and like it is a part of the Gujarat coast. So the outline you can just only identify. Again, I'm just giving an example of 72 meter. The same things we're just able to identify different type of means channels, means drainage channels, and the water bodies extension, and the color differentiation. Again, once it is the increasing this resolution, you can see that 5.8 meter resolution. So you are identified that the different types of plots are there, roads are there, different means the different linear features or the aerial features are visible. So once you are getting the 1 meter resolution, so you are able to identify each and every feature. So you are trying to, you may get the information of every plant. If this is the real, means there is a real line, how many paths are there? What is the means with these buildings? What is the extent of this building? So all these features are means clearly visible. So that is the fact that why you are going to use this special resolution data, or which type of special resolution need to be taken care during the designing of the project or designing the information or collecting the information. So that is based on your purpose of study or the scope of study that you have defined in your scope or in the project area. Next, the spectral resolution that already I have described in you earlier, like that electron spectrum, that we have the different sensor or the different objects having the different spectral characteristics. The water that is low spectral characteristics in both the bands, and it's comparatively high spectral characteristics in the blue band and low in the near infrared region. So why you are observing this water body is blue? That is because of its high reflectance of this water bodies. And in the same way, the vegetation characteristic you can see in the near infrared region there is a high reflectance, and the green band there is a high reflectance, but in the red band there is a minimum reflectance. So when you are trying to considering this characterize the vegetation, we need to consider the near infrared image, so that we are able to identify the vegetation extent or the vegetation characteristics of this particular area. And then soil. So in that way, each and every feature on our Earth surface having some different spectral characteristics, and these spectral characteristics, once you are getting means knowledge, having the knowledge of the spectral characteristics of the spectral behavior of the features. And recently, there are a lot of sensors are available. So sometimes, what we'll do, we'll just means collecting these informations or verifying these informations with the objects, and we have defined this spectral range or spectral characteristics of the features on the Earth surface, and same has to be reflected in the image to classify the objects. And then radiometric resolution, that is the capability of sensor to discriminate the gray levels. That suppose if we say that I can classify maximum, the human being can classify the 17 to 19 spectral characteristics or the spectral range, or the means as energy levels they can classify. But sensors have the capability more than 1023 or more than that. So based on this radiometric capacity, we are trying to, or we may classify the each and every features more accurately, or means in details by its means radiometric behavior. Like an example, you can say there are different radiometric resolution data. If you can see that 2-bit data, that is why 2-bit, that when you are classifying the 2-bit, that means 2 to the power 2, right? So, and 8-bit, like 2 to the 8. So like it is classified the energy level into 256 gray levels. So once you are able to identify these 256 gray levels, so the visibility of the features, or the means its texture of the features, will be much more accurate, or that will be very helpful for identifying the features at increasing the levels of the particular features. You can see that in 2-bit, we are not able to identify exactly what is the extent or what exactly. But when we are considering this 8-bit data, so that this vegetation you can see here, but you cannot identify these features without having any experience or knowledge about the study area that the vegetations are there, right? Next, temporal resolution. Why this temporal resolution? That means once we need to the collecting the data of means chronological data. Means historical data. So what we'll do, we just trying to identify the or collecting the information from the same angle and the same viewing point of the by fixing the sensor. So that sometimes people are trying to means means collect the information at crop health, like say for example, that estimating the growth of the crop, so that he will take the information at 15 days interval. So here I have you can say in temporal resolution sensor or the satellites, having the capability to gather this information at this particular height or particular means angle, so that users can able to identify the what is the exact growth, or is there any changes occurred or not. Sometimes we are trying to make a plan, so creating a developed plan by what are the historical changes are there. So based on that, we can propose where we can identify this data. So in that case, temporal resolution is much more important. Another important characteristics of the temporal resolution, like different types of natural phenomena or hazards which occur on Earth surface, like floods or earthquake or landslide, etc. So before the flood, what are the situations? So after the flood, what are the so in case of the damage assessment or the vulnerability assessment, this data is very much useful. So we need to when we are going to classify, or when we are going to recognize this type of information, then we need to consider this temporal resolution data, or so the sensors having the different temporal resolution, and based on its temporal characteristics, we have classified it like high temporal, medium temporal, or low temporal resolution. Low temporal, that means the sensor having a capability like more than 365 days, right? And in case of there are a lot of sensors like MODIS and ever sensors are available on our surface, that are providing the data, daily data, so that you can means identify the changes of the daily information, or you can acquiring the daily information about our surface. So this is a characteristics, there is one research paper that I've taken an example, that he has studied the expansion of the urban area of a particular region. So he has taken the features from 1985, 1995, and 2005, and based on that, he has identified what is the urban extent, and what are the settlement features or built-up areas are available and in this particular area. So this type of information, where we're going to analyze this historical information, or gathering the means database of the chronological changes of this particular features. So we may consider this type of information. So already have talked about the benefits. Anyway, now this is basically the basic important character, that there are two important data that are globally using. That I'll just give an example of the Landsat data of the UAC, and I'll provide another example of the Indian remote sensing satellite. So this Landsat data, which is introduced in 1960-70, of the years, that first Landsat satellite has been launched in 1972, having an 912 kilometer, which is known as the Sankar or the polar orbital satellites. And they're gathering the informations of the Earth surface, and still it is continuing. And then 1982, they launched Landsat 4 and 5. Why it is the number change, that I will describe later you. That you can see that there is some of the important features that is changed, like ground swath. Swath, that means the width, the area of the satellite that is covered to collecting the information. So this is known as the ground swath, which is 185 kilometer, whereas for the Landsat 4 and 5, the same is considered. But temporal resolution, you can see that 18 days for the Landsat 1 to 3, but whereas in Landsat 4 and 5, they have improved like 16 days temporal resolution. And another important characteristics is you can see here that the Landsat data for 1 and 3, they are considering the 80-meter resolution. But when the Landsat 4 and 5 have been launched, they have classified the different, and they have installed the number of sensor like MA6 multispectral scanner having 80-meter resolution, thematic mapper having the 30-meter resolution, and means the spatial resolution and the temporal resolution, they have increased, right? So in the same way, that Landsat 7, what they have done, they have increased the number of bands, they have increased the ETM plus data, and one panchromatic band, that is 15-meter resolution. So again, they have increased the spatial resolution, and they have also increased this thermal infrared resolution. Whereas in Landsat 4 and 5, you can see the thermal infrared resolution, which is that infrared band 120 meter. In the Landsat 7, they've increased into the 60-meter resolution. So you are able to identify the smaller features of our Earth surface having the 60-meter extension and its thermal properties using this satellite data. And the same way, they have launched Landsat 7 and 6 and 8. And then, however, Landsat 6 and 7, these are the failed the satellite. That is due to some technical error, and then they have launched. They have 7 and 8, and in currently 8 is the operational satellites, and in 2022, NASA is planning to launch the Landsat 9 also. So you can see these are the extension or the capability of the life cycle of the Landsat data that first initiated in 1972, and then it's launched up in 1978. And then again, the Landsat 2 it's launched, and Landsat 3 is launched, which is extended up to 1985. After that, Landsat 4 they have launched, which is again initiated during the 1984 and continue up to the 1995, and then Landsat 5 is continuing up to the 2012. And then Landsat 8 has been launched, which is extended from 2013 to 2020 approximately, or it's now continuing. Is maybe as per the proposed plan, they have extended up to the 2028, and then Landsat 9 will be launched. So this is the series of satellite the NASA is launching, because they are just improving the different types of spectral resolution. They are improving the spatial resolution and the temporal resolution of the satellite, so that people are able to gather these informations more accurately with 30-meter spatial resolution, or more sometimes 15-meter resolution. So and simultaneously, it will also helpful to increasing the temporal capability or temporal variability of the data, and so that the historical informations will be available to collect or analyze the particular features or particular area for predicting or for planning purpose. And this is the summary that when the satellites are launched, and when it has been decommissioned, and what are the sensors they have been used. However, this is extended up to Landsat 7. I have not updated Landsat 8 and 8, but Landsat 9, the details are not available in the data. So in Landsat 8, I will just give you example in Landsat. Yeah. Sorry, this is the example of Landsat 4 and 5, that what are the spectral bands in Landsat 4 5 we've used, and then what are the resolution of the each and every band. You can see the total number of bands there are Landsat 4 and 5, it's 7. And they have the different blue, green, red, and infrared spectral range, and sort of infrared and thermal infrared range. So and their spatial resolution, which is approximately 30 meters. Whereas in Landsat 7, you can see there are 8 number of spectral bands, and they are, whereas they have included this panchromatic bands having a 15-meter resolution, and the remaining characteristics of thermal bands of 60-meter resolution, the remaining characteristics are same. And this is the example of the different Landsat of thematic mapper data. You can see that different spectral bands. We are getting the information of different spectral band in black and white. But when you're combining this information, there is a 1, 2, 3 bands combinations. So color image will be there. There is a 1, 4, 5, and different. Why this is required? Because after combining this information that we have studied in our earlier slides, that each features having some different spectral characteristics of the spectral properties. So based on the spectral properties, we are able to identify these features, and we can gather the informations of the spectral characteristics of the features. And then this is the Landsat 8, which is used 11 spectral bands, and you can see that there are 2 thermal bands. Why these 2 thermal? We have seen in our thermal remote sensing, the most of the thermal sensors are using 8 to 14 micrometer regions. But again, if you consider the spectral characteristics of the spectral resolution, once we are classifying this spectral range, we are able to identify the features of the Earth surface, we are able to detect the Earth surface features more clearly or more in details, like it's based on its growth, or based on its extension, or thermal properties, etc. Okay. And these are some examples, that's applications that I've already actually collecting from the websites. And if you are already, I have shared the slides also. And these are already available in the websites. You can collect it and you can check it. Like, for example, I just give an example, like blue and green band, right? In the landscape data, they are mainly considered the useful of the bathymetric mapping, like in the coastal areas. What are the water depth that they are, and for distinguishing the soil means turbidity conditions, or the particles dissolved in the water bodies. So based on this blue and green band, you are able to identify the means different soils and vegetation characteristics of the particular area. And green band, which are emphasizing the thick vegetation or vegetation characteristics of the vegetation vigor, and the vegetation health, you can say, that of this particular regions. And there are red band that is also helpful for discriminate the vegetation slope. Like when you are going to identify this vegetation characteristics, we are using a technique that we will discuss in our digital image processing class, like say that normalized difference vegetation index. So why it is normalized? That as we have seen that the red band in the red band or red spectral channels, there is a minimum reflectance, whereas the near infrared there is a maximum reflectance. So that we are just using this normalizing algorithm to classify or to identify these features of the Earth surface or the vegetation characteristics. And then thermal properties, the thermal bands that has been basically used for the thermal mapping and the soil moisture estimation. It is also being used for the hydrothermal rock mapping and hydrothermal mapping of the rocks of the mineral deposits on our Earth surface. And there are some examples of the Indian remote sensing satellite that I've told you, like our Indian remote sensing satellite, first IRS-1A, which is launched in 1988, and this mission was completed in 1992. And the main focus of this IRS program was to land use land cover mapping, and to identify the agricultural area, forestry area, or the soil classification, and the coastal wetland mapping, and different other natural features of the Earth's surface. And then Lancet, sorry, IRIS P1, which was launched in 1993. This mission was failed, and then Indian Remote Sensing as Indian Space Research Organization have launched IRIS P2 in October 1994, and mainly for the focusing the land, oceanography, and atmospheric applications. And then in the web, like in IRSP6, this was set one is used in the 17 October 2003, and which is right now in service, and they are considering all the integrated land and water resource management, like whatever the features are available on the land surface. It's maybe the agricultural lands or the vegetation coverage or the buildings, whatever it is. So we are able to identify these features, all these features, using this remote sensing data. And this again IRSP5 Cartosat 1 is one was launched into having a spatial resolution of 2.5 meter, and this is the first satellite in the Indian remote sensing history that it will provide the stereo image. That what is the useful of the stereo image? That we are taking the informations in the two angles or the two different viewing points, so that once we are getting this information from the same area at the different viewing angle, we are able to identify its topographic conditions or the elevation characteristics. So this digital elevation model, that you may have heard this term. So in engineering, there is a lot of useful of this digital elevation model, or the different types of engineering projects. And so once you are getting able to identify these elevation slopes or aspects of this particular area, that is very much useful for planning or for designing of the project. And then some OceanSat tube, which was launched by Indian Space Organization for the ocean and atmosphere related applications. And then Researchers 2 was launched in 2011 by Integrated Land and Water Resource Management. And then that I was told earlier, like Indian remote sensing satellite, they have one Space Organization They have also designed different microwave satellite like Megatropics, RISAT-1, Sorol. These are the microwave satellites that is used for different types of identifying the weather phenomena, or the estimating the budget or energy of the different Earth surface features. They're also able to design this project like RISAT-1 program, specifically focus on the paddy monitoring. That we are living in the monsoon country, and during the monsoon season there are a lot of rainfalls and cloud cover are there. So from the visible remote sensing techniques, we are not able to collect this information. So in that case, the microwave remote sensing or ISAT satellite data or SORAL data will be helpful to get this information and to identifying the proper estimations of the crop acreage or the crop characteristics of this particular area. And then 2017 government of India or Indian Space Organization have launched the Cartosat 2D, where it is basically used for the cartographic applications and the R1 and rural applications, like defensible 3D modeling and identifying the features, which is a 1 meter spatial resolution. And they're also able to identify the different types of utility management like road network, water pipeline, drainage, sewerage, etc. available within the Earth surface. And based on this information, you can able to develop the land management information systems, as well as it can be integrated with the GIS system, so that there is a facility of the management information or the planners or the public citizen to getting this information about their infrastructure facilities or the utilities facilities, and based on that they can choose their plan, or they can choose their habitat of this particular area. And then there are some characteristics of the Indian remote sensing satellites, where you can see that in the IRIS-1A and 1B, there is a two type of satellites was mounted. That is, one is the LIS-1 and LIS-2. LIS, that means linear imaging self-scanning, right? This is categorized in the 1 and 2, and there we use the 4 spectral bands and having a spatial resolution of 72 meter approximately. Whereas LIS-3 in IRIS IC and ID, you can see that the spatial resolution of the satellite, you can see that 23.5, totally half of the IRIS-1A. And it's also, they have also improved the swath, like the extension of the sensor to capturing the information. And in IRIS-1C and 1D, Indian Space Organization also used the pan and waves. That is pan data, that means panchromatic data, having a spatial resolution of 5.8 meter, and the wide field sensor, which is 188 meter spatial resolution. Because these 3 sensors, they have been used for different purpose. Like these 3 sensors, they have used for the land and water monitoring or natural resource monitoring system. Pan system, the pan that is used to identify the details information identification. That is, you can see the pixel resolution, or that means the pixel size is 5.8 meter, and 188 the spatial resolution of waves, but it's temporal resolution, you can see 5 days. So that once you are would like to collect the information, so they are trying to collect the information as the 5 days interval of this particular area, so that what are the changes are there and what are the features have been developed that can be identified by this Indian remote sensing satellite. And then Indian remote sensing satellite, they have launched the IRIS-P6 also. That is the they have used the LIS-4 sensor, LIS-3 sensor, and advanced view sensor. So in that case, that in LIS-4 sensor, they are using only 3 spectral bands, like green, red, and near infrared. And the spatial resolution, that you are getting the multispectral data with a very high resolution sensor, like 5.8 meter, whatever we have seen in IRIS IC or ID, that is 5.8 meter for the panchromatic band. But here we can see that multispectral data we are getting at 5.8 meter spatial resolution with a swap, which also is very much enhances, like 70 kilometer, whereas it was approximately 142 kilometer. And the same way, the IRIS P5, they have launched in Cartosat 1, whereas they've used 2 different panchromatic band that I talked in our earlier slide, that the stereographic photograph has been taken to identify to develop the digital elevation model or the topographic variation, or to understand the undulation of the topography because sometimes we are able to we are planning for the hydrological applications like construction of the dam or the means reservoirs, or sometimes we are means different types of hard and fine that has to be developed. So in that case, the stereographic image is very much useful, and because of based on this image, we are able to identify the exact ground features or the ground's depth or its elevation characteristics. So, which is not means that may be possible for the conventional survey, but it will take too much time. But we can collect this information within a short period of time, or within a means very smaller time period. And after processing the data, we can process the model or develop the particular area or region within a very proper way. Or as such, also we can also combine this data with different associated phenomena, so that like habitation, vegetation areas, or agricultural areas, so that can be correlated or means improved. And next, there are some important sensors like Cartosat 2, and, launched in 2007, and like Sorrel 2011, and 2019 December, Government of India with collaboration with the Indian Space Research Organization has developed Cartosat 3, having 0.5 meters spatial resolution. So basically, these are useful for the urban mapping. Like once you are going to develop the base map or the base map features of this particular area, so we need to consider this urban mapping or the means high resolution spatial resolution data. That's all about the today's section of today's lecture. Thank you, all of you. So if you have any query, please feel free to ask me. And thank you, all of you. Thank you for your kind attention.
Thank you.
Thank you, sir.
So, due to our time limitation, that I need to cover all this means aspect within this time period. However, there are a lot of means informations are available. So yes, that is definitely true. That once you are in the first, or you are means. You don't have some preliminary information about the remote sensing, it's become difficult to in a single class to understand all these things in the remote sensing. But yes, definitely I'll try. Trying to level my best that to know about the basics of remote sensing, and the basic informations about the remote sensing that you need to consider or we need to keep in mind whenever we are going to analyze, or we are going to use this remote sensing data. And yeah, definitely you can call me, or you can feel free to mail me that I have share my first slides, my email ID and phone number. So we can talk and we can discuss whatever is it. Our based on my this class, I am requesting, if you have any query, please feel free to ask me. And I am also requesting Vijendra to take over, or if it's.
Yeah. Participant, do you have any question? Then ask in the chat box. If you have any query, please write in the chat box. So, sir, we don't have
Yeah.
any queries. We can continue the tomorrow on the tomorrow with further.
Okay, thank you, all of you. Thank you, Vijendra, for again. I'm very much happy that yes, it's a very good opportunity for me to share my view, and
Thank you so much,
definitely
sir, for
tomorrow again we will meet, and tomorrow's discussion on the digital image process. Thank you,
thank you
guys.
for thank you so much, sir, for today's session. We can continue with the tomorrow on the same time with the same link. Thank
Sure,
you.
sure, sure. Thank you so much.
Thank you, sir.
Thank you.
Participants, please leave the session. Thank you.
Thank you, sir.